Welcome, everyone. This is the start of our mini science series from McGill University. We are located on the campus, the downtown campus in Montreal, Canada. We are on the traditional territories of the Haudenosaunee and the Anishinaabe nations. McGill has long recognized, honored, and acknowledged these nations as the traditional stewards of the lands and waters that we meet on, we work on, we exchange information, and we learn from each other. To introduce our speakers for this evening is the student ambassador, Caitlin Law.
Hello. In today's talk, Professor Roy and Professor Otto from the Department of Psychology will be examining the impact that decision-making will have on the brain. To begin, Professor Roy will use brain mapping images to show the impact that pain has on a person's ability to make decisions. Professor Otto will then continue by talking about how features of our choice environments will impact a person's ability to make good restaurant choices. I will now pass it to Professor Roy.
Thank you, Caitlin. Today I will present a pair of studies that have examined how our brain decides between physical pain and competing monetary rewards. Okay, so as you all know, making decisions is difficult, but it seems that making the decision to willfully accept pain is particularly difficult. And perhaps an extreme example of that can be found in the movie 127 Hours that tells the true story of a hiker, Aaron Ralston, who had to make the decision to cut his own arm that was stuck underneath a rock to prevent from dying from dehydration. So even though this was definitely the right decision to make, it's the decision that saved his life. It's a decision that took him a very long time to make. It was a very difficult decision to make. Fortunately, most of the decisions that we have to make about pain are not always matters of life and death. So there are several examples of decisions like that. So for instance, if you are about to move a very heavy couch and you are afraid of hurting your back, you may decide to hire movers to do it instead of you. However, this decision to avoid pain very often will have to come at a cost, and it's important to pay the cost that the pain is worth and not more than that. So in this particular example, the cost that has to be paid is monetary, but very often it's not necessarily monetary. So very often the types of costs that people will pay to avoid pain is to avoid engaging in pleasurable activities. In this pair of experiment, we sought to understand how the brain decides what is the correct price to pay to avoid pain. This is a question that has a very high theoretical importance because according to Jeremy Bentham's famous quote, pain and pleasure are the two sovereign masters that dictate all of our decisions, all of our actions, and yet we still know very little about how the brain integrate pain and pleasure to make these decisions. It's also a question that has very high clinical relevance because it is thought that excessive pain avoidance is an important part of the vicious circle that leads from acute to chronic pain. In order to tackle that question, my postdoc, Dr. Hussein Slimani, and me designed the following experiment, where very simply people had to decide to accept or reject combined offers of pain and money. So for instance, in that particular example, for that particular trial, the participant was had to accept or reject a an electric shock that was set at an intensity of 24 out of 100 in exchange for $7.78. Okay, so they have to decide yes or no, do you accept or reject the offer? So of course, we add ethical considerations when running that experiment. And so before participants engaged in the main task, they went through a calibration procedure where we identified 8 different pain levels that were between 0 and the maximum tolerance for that participant and for that particular experiment. So we never made offer that were over the participants' tolerance limit. And so if the participants wanted to have the money, they had to accept the pain. So in that first version of the experiment, we had 8 levels of pain and 16 levels of monetary offers. And here we see the result from one exemplar participants. So in X, you have the pain offer. In Y, you have the monetary offer. In yellow, you have the trials where the participant accepted the offer. In blue, you have the trials where the participant rejected the offer. So the first thing that we did is that we took these choices and we tried to model them using a logistic regression model. And we see the result of that on the right here. So here, the different colors represent the probability of accepting or rejecting a particular combination of pain and money. And what was interesting for us here was the green line here in between the blue and the yellow zone. And the green line represents the pairs of pain offers and monetary offers that are associated with a 50-50% chance of accepting or rejecting the offer. So that 50-50% level corresponds to the indifference point, and it represents the value in money that the pain has for that particular participants. So we did that for all of our participants, and here are the average pain value functions in the different groups of participants that we tested. So for this first behavioral study, one question that we had was whether or not pain value was relative to the range of monetary rewards that were offered in order to compel people to accept the painful electric shocks. And so in the first group, the range of pain offers was between $0 and $5, and the different monetary offers were equally spaced. In group number 2, the range was between $0 and $10, and again, the different monetary values were equally spaced. In group number 3, we had a range of offers between $0 and $5, but here we had more offers in the low range than in the high range. So more specifically, the gap, the space between the different offers increased exponentially. And so maybe some of you are wondering where their taxpayer money is going with these types of experiments. So in order to prevent from having to pay too much money to participants, we employed a trick here that's commonly used in behavioral economic studies. And so we didn't pay the rewards on every trial. Rather, at the end of the experiment, we made a random selection of 10% of the trials, and participants received the rewards that were associated with this random 10% of trials. So this procedure that helps reduce the costs of experiments like these and has been shown in the past to not have big effects on people's decisions. But we also wanted to be sure of that. And so in a smaller subgroup of participants, we really gave them the money that they chose by putting them in front of them in a jar to make sure that they really understood that they were really receiving the money. So that's group number 4. So for groups 1 to 3, we had 30 participants per group. For group number 4, we had 6 participants. And here on the top left, we have the group results. And what you can see is that the range of monetary offers seems to have an impact. So if people are offered more money, they are going to ask more money to accept pain. So group number 2, the pain value is higher than for group number 1, and group number 1 is higher than for group number 3. There also seems to be a small effect of directly receiving the money in a jar placed in front of the participant versus the random draw at the end of the experiment, but the effects weren't so dramatic. And the other thing that we observed that was interesting was that the pain value function isn't a straight line. So the slope of the function increases with increasing levels of pain offers. So what that means is that as the offers approach the tolerance limit, pain gains more and more value more rapidly. Okay, so choices between relatively low levels of pain, the level of pain doesn't really matter here, but as pain increases, it becomes more and more important. All right, and by and large, the goal of that first experiment was to make sure that people are able to make rational decisions about pain and money. And here, clearly, people are able to compare the two and make sensible decisions. So the next step for us was to bring this experiment into an MRI scanner. And this was done with my postdoc, Dr. Michel Pierre Call. So we ran the same experiment in the scanner. And here, more specifically, what we were interested in was to try to understand how future pain and future money are represented in the brain before they are integrated so as to inform our decisions. And in order to do that, we were very careful to separate the pain from the money offer. So in order to do that, half of the trials started with a monetary offer. So in this example, this particular trial started with the monetary offer, and half of the trial started with a pain offer. So this is what we call offer 1. Then after a little pause, the second offer was presented. So in that case, the shock intensity was revealed. And this is when participants had all of the information that they needed to make the decision to accept or reject the pain and money offer. So doing that allowed us to separately examine the representation of future pain and the representation of future money. Also, since there had already been quite a lot of studies on the cerebral representation of future rewards, we were more interested in the pain part of the experiment here. And more specifically, we asked ourselves how similar is the representation of pain, of future pain, how similar is it to the representation of future monetary rewards, of actually experienced pain, and how similar is it to negative emotions. So in order to answer these different questions, we used a pattern matching approach where we employed machine learning algorithms to train a pattern of brain activity to predict the level of the pain offer. So this is what we see on the left here. So regions of the brain that have yellow on them represent regions of the brain where activity is positively associated with the level of the pain offer, and regions with the blue color represents regions of the brain where activity is negatively related to the value of the pain offer. On the right here, we see the relationship between the level of the pain offer and the predictions that we could make by using this pattern of brain activity. Each line here represents a participant. So we had 60 participants for that second brain imaging experiment. And we can see that the model is quite good at tracking the pain offer level. Here we have the actual correlation coefficient for each of the participants, and we can see that for most of the participants, these correlation coefficients are well above 0. And finally, on the right, we have the level of expression of that pattern that we see on the left here as a function of the pain offer level. And we can see that at the level of the group, this pattern is pretty good at tracking the level of the pain offer. When we look more closely at the particular pattern of brain activity, there were 3 main things that stood out for us. The first one was these negative predictive weights that we found in the ventral striatum. This was particularly interesting for us because the ventral striatum is generally associated with rewards. It's the brain's reward center. And to see it negatively related to pain was interesting because it really suggested that there was a lower reward representation associated with high pain offers. The 2 other regions that were interesting for us were the dorsal striatum and the intercingulate cortex, and we will discuss these regions in 1 or 2 slides. So we did the same thing for monetary offers. So this is the pattern of brain activity associated with the level of the monetary offer. And it is mainly comprised of a big cluster of positive weights in the ventral and dorsal striatum. So the next question that we asked ourselves was in which region we could find a shared patterns of representation between pain and money. And here in this figure, we see the regions that encode pain level and money level in the same way. So in yellow, we have the interior cingulate cortex and the dorsal striatum. And these regions are thought to harbor a unsigned value representation. So what that means is that they encode pain and money level in the same direction. So in this case, they were positively associated with increasing value of money and increasing value of pain. And this suggests that these regions are related to the general salience or importance of the decision. Okay, so regardless of whether it's good or bad, these are decisions where the stakes are high. What was particularly interesting for us, again, was to see this signed shared value representation in the striatum. So what that means here is that the value representation in the striatum was the same for pain and money, but it was going in different directions. So it decreased activity with increasing levels of pain, and it increased activity with increasing levels of money. And this was particularly interesting because it suggested that we can use, our brains can use the level of activity in the ventral striatum to choose what is, to compare pain and money and to choose what is the right price to pay to avoid pain. So as I mentioned earlier, the second question that we asked ourselves was how similar is this representation of the value of future pain with that of immediately experienced pain. So in order to answer that question, we identified the pattern of brain activity associated with the intensity of the shocks that were delivered. So this is the pattern that we see on the left. And what we observed was that that pattern was largely dissociable, could be largely differentiated from the previous pattern of pain value that we had identified. this is what we see here. So if we try to use the pain value pattern to track shock intensity, it doesn't work. We have a flat line. So the pain value pattern isn't sensitive to the intensity of the shocks that were delivered, and vice versa. If we take this shock intensity pattern and we try to use it to track the level of the pain offers, we also get a straight line. So it doesn't track the level of the pain offer. So we had a dissociations between the two, which suggests that the representation of future pain is largely different from the representation of immediately experienced pain. And finally here, the last question that we asked ourselves was, how similar is this representation of pain value to that of negative emotions more generally? So here we had to rely on the results from a previous study conducted by Luke Chang and Tor Wager, where they developed a pattern that was predictive of the negative emotions experienced when watching aversive pictures. So the particular pattern is called the Pines. And there we observed similarities between anticipated pain and negative affect. So if we take our pain value pattern and try to predict the negative emotion experienced in that study in response to aversive pictures, we see that the pain value pattern is able to track these negative emotions. Okay, so it's not a flat line, it tracks the negative emotions, and vice versa. If we take this pattern that was originally designed to track the negative emotions experienced in response to aversive pictures, we see that it can be used to track the level of the pain offer. And when we look for regions of overlap, we observe that there was shared representation in the anterior cingulate cortex and in the anterior insula, which suggests that these regions encode the general negative affect that is associated with the prospect of future pain and aversive pictures. So after we had characterized the cerebral representation of future pain and future monetary reward, we examined how they were integrated to predict decisions. So in order to do that, we looked more closely at brain activity during the offer to phase. Okay, so if you remember, our pain value pattern and our money value pattern, we developed based on activity in the first offer. And now we're using these patterns to try to predict the choice during the second offer period. So before I get into the more technical analysis that we did to demonstrate that, I just want to give you a first general glimpse at the rationale behind that last analysis. So here, if we take our pain value pattern and apply it to that offer number 2, we get the figure that we see here in blue on the left. Okay, so on the x-axis, we have the intensity of the pain offer. On the y-axis, we have the monetary offer, and the different shadings of blue represent the level of expression of the pain value pattern. And here you can see that the pain value pattern is pretty good at tracking the level of pain as it is supposed to do. Same thing with the money value pattern here. So here we can see that the money value pattern is good at tracking the level of the monetary offer. Okay. And now what's interesting is if we take the difference between the pain and the money value patterns, we get this graph here. And in this graph, we can see the same diagonal that we had when examining the actual choices to accept or reject the offer. So on the right, we have the actual choices. On the left, we have the difference between the pain and money pattern. And so it seems just at that level that the brain is probably doing something like subtracting the activity in the two patterns in order to make its decision. And so to test that hypothesis more precisely, we used a support vector machine algorithm to try to predict the decision to accept or reject the offer based on the expression of the pain value pattern and the money value pattern during offer two. And this is what we see here in the graph on the left. So the x-axis represents the pain value pattern expression level. The y-axis represents the money value pattern expression level. The different dots here represents different combinations of pain and money offers. The blue dots represents combinations that were accepted by participants. The red dot represents the combinations that were rejected. And the diagonal here represents the decision function of the support vector machine model. So for any combination of pain value pattern expression and money value pattern expression that is above the diagonal, the model would predict that the participant will accept the deal. And for every combination of pain value pattern expression and money value pattern expression that is below the diagonal, the model is predicting that the participant will reject the offer. And here on the right, we have the performance of this model. So more specifically, we tried 3 different models. So one model with just the pain value pattern expression, one model with just the money value pattern expression, and one model with both of them. And this is the last model that we see on the left here. And what we can see is that the 3 models perform above chance, but that we get the optimal performance when we combine the pain value pattern and the money value pattern. So this suggests that the brain really compares these 2 patterns in order to take its decisions. So in summary, we saw that people can make choices that maximize gains and minimize pain, but these choices tend to be relative to the range of possible pain or rewards. We also saw that the value of future pain and monetary rewards share a signed representation in the ventral striatum that can be used for making these choices. We also saw that the value of future pain doesn't seem to share a representation with immediately experienced pain, but it shares a general representation of negative affect with aversive pictures in the anterior cingulate cortex and anterior insula. So it seems that there's more than just one system that is involved in these decisions between pain and reward. And finally, we saw that the value representations of pain and money can be used to determine future choices. And so on that, I would like to thank you for your attention. And I would also like to thank the colleagues who have participated in these studies, as well as the funding agencies. So thank you. And on that, I will end it off to Ross.
Okay, thank you. Let me switch screen here. Okay, I think we're good. Whoop. So yeah, I study something similar, but different from Mathieu. So we both study decision making in varying sort of contexts. One of the things my lab and one of the things I'm interested in is real world behavior. So how can we find massive data sets in the real world that actually let us say something about the way people are actually making decisions in the world, as opposed to in the lab. And so you might ask, okay, why would we want to do this? So why use naturalistic data? So the first point I think is somewhat obvious, but I think it's worth making again, right? What we're interested in explaining as psychologists is people's real world behavior. So there's an obvious benefit, right? If you consider what we call external validity or ecological validity in different fields. Oftentimes, and I think this is the case in what I'm going to talk about today, we can circumvent practical limitations of lab experimentation. So instead of looking at artificial choices, we're going to look at choices that are, for example, economically or personally consequential to people. Instead of, say, in the laboratory where you have these often small stakes or artificial choices. I think that the next benefit is equally important, just by virtue of the sheer size of some of these data sets, right? And not only that, but the diversity. So getting outside of university participant pool communities and actually talking about what do people in diverse kind of geographic and demographic segments of the population do is worth examining. And finally, these can often be low cost or free relative to the amount of data or insight you can get. So more substantively, what I'm interested in talking about this evening is context effects in real world choice and evaluation. So let me unpack that a little bit. So there's a vast history of literature. Actually, a lot of this goes back to Danny Kahneman, who famously got the Nobel Prize, behavioral economist. And there's this idea, right, that our perceived value of something, or you could call it our subjective value, depends on the values of the other options under consideration. Or you could call this the context, right? So I think many of us have seen, for example, this is a confusing coffee menu in Japan with the prices in these different columns. The idea is that this menu is constructed in such a way as to make people essentially fall prey to these context effects and buy the most expensive or largest size drink. And just in the laboratory, right, there's a huge body of work across economics and consumer behavior and psychology as well, kind of outlining and describing these so-called context effects. So again, this idea that our valuation of things is relative, right? It's not absolute. And so the question we set out to answer is, are these context effects observable in the real world? And to do this, we're going to consider the case of restaurant choices and ratings on Yelp.com. So I'm going to assume everyone here is familiar with Yelp.com. In brief, right, it's a place where people leave reviews for restaurants, but it's at least up until recently was the most widely used website and app of its sort. So there's tons of data there. So right, the other kind of interesting thing here is this lines up well with dinner time or getting close to dinner time, depending on where you live. So I'll try to keep this short, keeping that in mind. So I think one of the most compelling pieces of evidence for these context effects actually comes from my collaborator on this project, Kenway Louie, who was at NYU. And what he showed was, okay, if you have people make choices, for example, between an array of 3 snack foods, and these are real choices, so you have to consume the thing you chose. What you find if you construct a choice set for a given person, imagine there's 3 options. You have the highest value option, and this is idiosyncratic. So this is we know the values of these options for a particular person based on how they previously rated them. And you have to make a choice between these 3 options. Importantly, 2 of them are valuable. So the thing on the left, this granola bar thing, right, and this bag of chips are your high value options. The chips is the highest value option for this particular person. But in the middle is this thing called what we call the distractor option. So that is an option with low value that you should not consider. In other words, whatever is going on with this option should not bear upon your choice between the other 2 options. And so what you see, and this is your kind of classic context effect, is as you increase the value of the low value distractor, that is as the irrelevant option of low value increases in value relative to these actually viable options that are valuable to you, you are less likely to make choices to this highest value option. Importantly, you're not making choices to this low value option, right? To this distractor option, you're actually becoming more and more likely to make choices to this other valuable option. So in a sense, right, the value of this irrelevant option that should have no bearing on your choice between these outer two options is actually affecting your ability to choose the most valuable option. And so what we tried to do was show how this sort of context effect might play out outside the laboratory in the real world. And so that what we turn to again is restaurant ratings on Yelp. And these have a number of desirable properties. One of which is, okay, unlike other types of businesses, what options compete with one another in a very real way, right? As people typically visit one restaurant per meal, which means you have to choose one place, right? Often among several to go, say, have your dinner. And the categories of restaurants are reasonably well defined, right? So you can fairly easily segregate options in a city, right? You can say these are pizza restaurants, these are sushi restaurants, et cetera, et cetera. And also the sheer size again, right, of this data set. So we're going to look today at around 4.2 million ratings across 11 metropolitan areas in North America. And here, just for your curiosity, right, is the count of ratings of restaurants, or rather histogram of restaurant ratings. So you can see, right, that there's this kind of stereotypical thing you see where most restaurants, right, are rated somewhere between 3.5 and 4.5 stars out of 5. But that's just to give you an idea, right, of what these ratings look like. So the approach, right, if we want to look at choice, is that we view each user's restaurant rating as a choice to visit the rated restaurant at the time of review. So to give you an example, right, if Jane Doe has rated this particular pizza place, right, on this date, that's evidence that, or we take that as evidence, right, that she in fact visited that restaurant among some competing options, right, or rather chose that restaurant among some competing options at the time of choice. And so what we can do here to look for these context effects is examine choices and later ratings, which we'll talk about for a few minutes, with respect to the similar competing options in that neighborhood. So, for example, these are pizza places in a particular neighborhood in Pittsburgh that we presume Jane Doe chose between. So names have been changed to protect the innocent here. So to do this, we had to do a little bit of GIS just to figure out how to infer these so-called choice sets. So the presumption is that when you're in a particular neighborhood of the city, you're only going to consider nearby options. So, for example, thinking about the category of pizza restaurants in Pittsburgh, right, there are 37 sort of geographically coherent clusters of restaurants. So each of these clusters, right, of colored dots refers to pizza restaurants in a particular neighborhood. So, for example, these purple dots, right, this is one neighborhood, right, with 6 pizza places in it. And we can look at the distribution of star ratings of the options. So these are the average star ratings, right, at the time Jane Doe presumably chose the restaurant. So this isn't a particularly good neighborhood, right? The mean star ratings just over 3 stars. What you see here, right, depicted in this orange cluster, right, is another neighborhood, right, where things are somewhat better. So in this way, right, we can define the value, the overall value of the choice set, right, by the mean star rating. That is, how good is the context, right, or how good overall is the set of choices between which options between which you need to choose. So the first order question here then is, does the composition of the choice set, that is, does how valuable the choice set is overall affect one's ability to make a ratings maximizing choice? That is, are we more or less likely to make the choice to the best rated restaurant, right, in a good context versus a bad context? And so what I'm going to plot here is the probability for all of the users we've looked at across all of these choice sets of choosing the highest rated option. On the x-axis here is the mean star rating of the choice set. So in other words, what's the average quality of that set of options? So these are just the 2 example neighborhoods we talked about. So this would be a good choice set. This would be a not so good choice set. So what we see is that people make worse choices in higher quality choice sets. So this is, I think, fairly clear-cut evidence for a context effect, right? So in other words, the values of the other options among which you are choosing affects your ability, right, or each user's ability to make a so-called optimal choice, that is, choose the best option in the set. On the right here is the same thing broken down by different size neighborhoods. What I think the thing to note here, right, is that this downward pattern, right, is preserved, right, or is seen across more or less all of the sizes of choice sets. So this isn't something that applies just to big choice sets or to small choice sets. That is choice sets with a lot of options in them or few options in them. One of the things we tried to do, right, so here we're taking rating behavior as a proxy for choice. One of the things we wanted to do was show how this is actually true in restaurant ordering behavior. So there is a food delivery app that is widely used in the UK called Deliveroo, which our collaborator Eric Schultz over in Germany has been analyzing, or rather has been analyzing the data from Deliveroo. And what he's found is something similar. So for example, here's what you would see on the delivery app if you look for breakfast places in a particular neighborhood in London. What we see is that in higher overall quality choice sets, users are actually making worse orders. That is, they're ordering from, they're less likely to order from the best rated restaurant in the choice set. So I think that's a nice and important replication to do of our Yelp data. Possibly more interesting is the actual rating behavior itself. So not someone's choice to go to a restaurant, but what star rating did they leave when they went there? And so we can draw some inspiration from a well-known quote attributed to Tom Magliozzi. He said, "Happiness equals reality minus expectations." I'm sure we've heard this trope in our daily lives a lot. So kind of extending that idea, right? We could imagine user ratings, that is the star ratings that people leave, as some kind of product or some kind of outcome of a comparison that the user is making between their expectations of a restaurant's quality and the actual quality of the restaurant when they visited. So importantly, right, what we think of as these expectations should be contextually bound. That is, and I'll give an example of this in a bit. So just to kind of put this in kind of pseudo math here, what we think these star ratings actually reflect is the user's experienced utility, that is how good their experience actually was of going to the restaurant, minus their expectations. Okay, so again, thinking about this in the context of choice sets, or rather thinking about this as a contextual thing, right? If you imagine that the restaurants you're choosing between are say structured like this, so you have a couple low-rated restaurants and one high-rated restaurant, your contextually bound expectation of this place in the middle, right, would be rather high. So you could say, okay, I had great expectations for this place, right? Again, this is the rating of the place considered in light of its context, right? So a good place surrounded by bad places will result in a relative, a high expectation, right? In a kind of relative sense, right? Then you could ask, okay, when you actually go to this place, it's pretty good, right? It's not great. So now what you have, right, is this some kind of mismatch, right, between your experienced utility, that is reality, you could say, right, minus your expectations. And so what that would result in our account here is a not very good review, right? So Jane Doe would leave a kind of so-so review. So 3 stars is low, at least in the purview of Yelp restaurant ratings. So the question is, does this actually pan out in the data? So just to rehash the question, does context affect users' ratings of restaurants? So that is, do the values, right, of the other unchosen options push up or down ratings that people leave? And so I'm not going to go into this just for the sake of time. What we're actually going to analyze here is what we call the rating deviation. So this is the difference between the user rating and what we think of as the objective value of the place before they went there. So what we're trying to predict is this so-called deviation. And again, like the last plots we saw of choices, we're going to plot out this rating deviation as a function of how good the choice set is. So the context. So on the left side here, low value context, on the right side here, high value context. And what you see here is this quasi-linear, right, increasing relationship. So what this suggests is that users' ratings are systematically inflected by the context they made the choice in. That is the average quality of the choice set. And importantly, this qualitative relationship actually lines up well with our idea, right, of, again, ratings reflecting this mismatch between the experienced utility and our contextually bound expectations for restaurants' quality. Finally, if this is true, right, if the user rating actually reflects this kind of comparison process, all we really have access to, right, is the user's final rating of a place. So we can observe that Jane Doe on this date gave a 3-star rating of this particular pizza place, but we don't really know what their expectation was, right? This is a kind of hypothesized quantity in our view. So one question is there some way we can directly measure what these contextually bound or contextually modulated expectations look like? Because that would actually support this view. And so what we did was we went back to the laboratory. So this study was done by my graduate student, Sean Devine. And what we asked was the simple question, are expectations of restaurant quality contextually bound? So what we did was we actually took choice sets drawn from real world Yelp data. So a bunch of people in the laboratory, a bunch of experimental subjects rather, saw, for example, on this particular screen, they see a list of 3 Mexican places. This is real data, right? So this is, in a sense, realistic. And then all we did was we asked them, okay, stare at these choices for a while. Here's the star ratings, the prices, some other incidental information. And we asked them, okay, imagine you ended up at this place. How satisfied do you think you would be with this restaurant if you wanted to go to a Mexican restaurant? And then they just move this slider bar. So what we're doing is we're asking them to make a rating, not of how good the restaurant is, which we can't do because we're in the laboratory. This is all hypothetical, but rather, how good would you expect this place to be? And we didn't instruct subjects to consider the context, right? We were looking for sort of a naturally occurring context effect. And what we see here is that, again, like the other analyses, the choice context, that is the value of the choice set of the unchosen options, systematically inflects these expectancy ratings. So when a subject is asked to rate how good they expect a place to be in a really good environment, right, in a really good choice set, they'll make a low rating, right? When they're asked to rate a similar place, right, in a low quality, right, or a low value environment, they'll make a higher rating. And again, this is a kind of roughly linear, monotonically decreasing pattern. So it suggests, right, again, that context is systematically inflecting, or rather systematically changing these expectations of restaurant quality. So I think that provides nice evidence, right, buttressing our theoretical account of the real world rating data. And so I think with that, and the fact that we just talked about food for 10 to 15 minutes, I should probably wrap up here. So the conclusions, right, are that we found, again, restaurant choices are systematically affected by choice context. To our knowledge, this is the first time such an effect has been shown in the real world. What we also see, right, is that user ratings are also similarly inflected by the composition, right, or the goodness of the choice sets faced. And so I think the big implication here, right, is, okay, I think many of us are familiar with the adage, it's all relative. This really suggests, right, that even in this kind of real world case, right, of restaurant choice, we evaluate everything in a relative fashion in accordance with its context, right? Very little of the subjective values we either act upon or rate is done in an absolute manner. And one kind of open question, which we'd like to resolve in future work, is, okay, what we've done is we've showed how people are sensitive to these observed these observed facets of the environment on Yelp. So in particular, how good are restaurants measured by their star ratings? But one possibility, right, is that people are actually using local knowledge, right? So there's a good body of evidence from the consumer behavior literature that suggests that these ratings actually map onto the true value of things quite accurately. And so if someone lives in a city, right, and has a good idea of what the restaurant sort of landscape is like, maybe they don't need to use these star ratings to make their choices, right? Maybe this information is actually coming from their own experience, right? Or even word of mouth. So this is kind of an open question. For the purposes of our conclusions here, we're sort of agnostic to the answer of it, but nonetheless, I think it's interesting. So wrapping up, I'd like to thank my collaborators. So Kenway Louis at NYU, Aaron Bornstein at University of California, Irvine, my graduate student, Sean Devine, and Eric Schultz, who's now at the Max Planck in Tübingen. So there, I think I should stop, and I guess we go to Q&A. Is that right?
Yes, we're going to go right into the Q&A from here. I guess our first question will go to Dr. Otto. From your results of your study, do you think that we actually make bad choices?
I wouldn't say they're bad. I mean, it looks bad in the sense that people are going to lower rated restaurants, but I think what they're doing is being efficient. So if an environment is particularly good, maybe it doesn't matter as much what you do. And there's a whole body of work in computational neuroscience, right, suggesting that the way we sort of code information in our brains is actually set up to maximize this kind of efficiency. So we don't want to waste brain power, for lack of a better word, trying to represent minute differences between options, right? If the actual marginal benefit of going to the top rated place isn't that great.
Okay, and then a question for Dr. Hua. What other primary sources of reward, other than money, such as maybe food, would they end up producing the same results of brain activity from your study?
Yeah, so that's a good question. So in our study, we used money, and money in a sense is just pure abstract value. And so that probably explains why we mainly just saw this big cluster in the striatum. By contrast with pain, which had a much more diversified representation. There were different brain regions involved, and that probably reflects the complexity of pain. So perhaps if we had chosen another positive reward other than money, such as food, probably we would have seen other regions associated with the emotional and sensory aspects of the food. So in that case, that would be the orbital frontal cortex that seems to be associated with food rewards.
Okay, great. And then another one for Professor Otto. What other real world choices do you think the context of your study might show up in?
I think all kinds of choices. So, but I think the most obvious one, right, is if you consider like dating markets, right? Things are very much relative. So you might expect different behavior if someone is without naming specific cities where things might be good or bad, right? People might be exhibiting different kinds of behavior, right? As a function of the context, that is, what are the other available options? I think another option, another kind of place, right, is choosing a career, right, or choosing between, say, competing job options.
And another one for Professor Roy. What would you predict would happen if participants had to choose between two adverse outcomes?
Yes, it's a difficult question. So we're currently running a study on. Can you repeat the question again? Sorry.
Sure. What would you predict would happen if participants had to choose between two adverse outcomes?
Yeah. So we're currently running an experiment on intertemporal choices with pain. So do you prefer pain now or later? So in this case, the outcome is pain in both cases, but the temporal context makes it worse. So it seems that people prefer to, against our initial hypothesis, people prefer to have the pain now rather than later. And in that case, I think we would predict to see the same kinds of brain signature track the value of pain. I also realized that we also did another similar study with Ross on decisions between pain and effort. So there we asked people to choose between experiencing pain and performing a difficult task. And depending on the ratio of pain and effort, sometimes people prefer to experience physical pain rather than spend kind of effort. And so in that case, the prediction would be a little bit more difficult. So I would presume that we would still get this sign value representation in the ventral striatum, but for the other aspects of effort, we still don't know. I would perhaps make prediction with regions related to executive function, like the dorsolateral prefrontal cortex or something like that. But I think the take-home message is that when you look at the brain, when it's making these decisions, some of the activity that we observe is directly related to a common value or a common currency that can be used to choose between different types of outcomes. And another part of the brain response to these offers may be more specific to the particular good that people are making choices about.
Okay, and I think Ingrid's just going to say something to finish it off.
Thanks, Caitlin. Well, I get to thank the speakers officially with the gifts. Not painful, but I hope they stimulate your pleasure centers. You get a postcard from the Red Path Museum. It's a stereoscopic postcard. When you open it up and look through it, it's a 3D postcard. You get to see this dinosaur in 3D. The Red Path Museum is Canada's oldest museum. It is located at McGill. It was opened in 1882. It used to be open to the public. We are closed right now, but we're still working. We're sending you things like our publications. You can buy these. Please let people know that there are still things from our gift shop available, especially these publications. These are like having the gallery, you're not going to the gallery, but you get it all in a book. So this is all the minerals in the mineral gallery. I've tucked in our little bookmark here. You'll be getting this by internal mail. This was a bookmark that we created at the museum based on a letter that we have in the collection. It was a letter written by Charles Darwin to the founder of the museum, a man named John William Dawson, in 1871. So that is part of your gift. And the last part is the face mask. I hope you can still use face masks. I'm sure there'll be a reason to use face masks. If not, you have a souvenir, a memento of a historical period of time. McGill Outreach, still doing outreach, but doing it safely. The Red Path is right now also running a campaign, a fundraising campaign. We've built discovery boxes that instead of us going out to schools or schools coming in to see the things we have at the museum. We'll send them out in a box. And we really want these boxes full of fossils and minerals and nests and skeletons, bones. We want them to get out to remote communities for sure, and underserved groups. These are exploratory boxes. So you'll see a little bit of a promo here. This campaign is running as part of McGill 24 crowdfunding. It ends May 12th. All donations are welcome. We'll see you back here next week, March 30th, 7 o'clock, McGill YouTube, for our second mini science presentation. Thanks, everyone.
Thank you.
Thanks for having me.